This is the Radio Frequency Quadrupole for the PXIE Accelerator here at Fermilab. It was made by Lawrence Berkeley National Lab in California. They've had a team of several people there working for, I believe, 3 or 4 years to design and build this hardware, kind of culminating in this morning's delivery. The big complexity of this hardware, I would say, is the machining and the fabrication of it. So the inside of it has a special shape that accelerates the beam when excited at the right frequency. And because it's at the low energy end of the accelerator, the beam actually speeds up noticeably as it goes through the RFQ. So unlike a lot of our cavities where it's just the same shape repeated, the shape of the accelerating structure has to actually change significantly along the length of the RFQ. So it's kind of state-of-the-art machining. We've got tolerances down to 10 micron scale, so it's pretty challenging machining and fabrication.
We are standing in the PXIE enclosure where we're going to be doing experiments on accelerator concepts that we are planning on using in PIP2. Behind me is the ion source and LEBT, or low energy beam transport line. We call it LEBT for short. The RFQ will be connected to this end of the LEBT right at this point, okay? And it is 4.5 meters long, so you can imagine it spreading out into this enclosure. So the next step is we put the RFQ in place and hook it up to the water cooling and the power amplifiers, and we turn it on and make sure that it can handle the power that it's supposed to. Once that's complete, then we will actually set up a small piece of what we call the medium energy beam transport, or MEBT line, with a beam dump, and we'll test beam coming out of the RFQ.
So the context of it is that PXIE is a test bed for the future PIP2 accelerator. So this is a key component to it and the major room temperature accelerating component of PIP2.